During last lecture, we started with various failure theories. And as far as concerned with these different failure theories, up till now we have seen the maximum stress theory and maximum strain theory. Okay. So these two theories of failure that are based on the stresses and strains. Is it okay? Whenever we have seen the maximum strain theory, at the time of maximum strain theory, we have seen this failure envelope also. So during last lecture, we have seen the concept of failure envelope. For maximum strain failure theory, in case of composite material, one important thing we should keep in mind is that maximum shear stress theory by Tresca and maximum normal strain theory by Saint Venant. So that two theories are referred in order to give the results in case of composite lamina by using maximum strain failure theory. Okay, so this is very important in case of maximum strain failure theory, that this particular theory is based on maximum normal strain theory by Saint Venant and maximum shear stress theory by Tresca. Is it okay? So these two things we should keep in mind, that what are the references of maximum strain failure theory. The one reference is maximum normal strain theory by Saint Venant and maximum shear stress theory by Tresca. Is it okay? Which are applied for the isotropic materials, same are used here in this lamina also. Is it okay? So now this theory is given. The minus indicates compressive, plus indicates tensile. So compressive strain and tensile strain. In between that, the stress along direction 1, strain in a direction 1 is given. 1 represents the direction. Is it okay? So direction, reference direction is 1, reference direction is 2. Is it okay? These are two reference directions. In the first reference direction, compression, and in second reference direction, compression. Is it okay? So E1 epsilon 1 C represents the compressive strain in direction 1, epsilon 2 C represents the compressive strain in direction 2. Compressive, that word is used, that's why this negative sign is present in both the cases. The strain along direction 1 and strain along direction 2. Is it okay? Here this is tensile in nature. So for direction 1 tensile, for direction 2 tensile. Like this we can consider here the strain values. Is it okay? So for this figure we have considered, we have noted it as a failure envelope with reference to this strain theory. Is it okay? The notations used here: ultimate longitudinal tensile strain in direction 1, ultimate longitudinal compressive strain in direction 1, ultimate transverse tensile strain in direction 2. Is it okay? Gamma 1 2, ultimate in plane shear strain. These are the notations used. Is it okay? Now I will not go much details on in the numerical part of that, but we should once again I will repeat the thing, that this particular theory of maximum strain failure theory is based on Tresca and Saint Venant's principle. Is it okay? This is the basis for that. Then Seil failure theory. In that case, the theory is based on the distortion energy failure theory of von Mises. Is it okay? See, in maximum strain failure theory, whatever the reference used, that reference was based on Saint Venant's and Tresca. So Tresca was used for the shear and Saint Venant's was used for this regular kind of strains, and in both the cases the reference is these theories which are applied for the isotropic materials. Is it okay? Now as far as concerned with this next type of theory, which is the Tsai-Hill failure theory. The Tsai-Hill failure theory, which was not considered in case of isotropic material, because earlier when you studied in second year in analysis of mechanical element, the fundamentals of various material related things and relationship between various stresses and strains. At that time also, there was no any concept which was related to the anisotropy. In case of machine design also, we have studied these failure theories inside that maximum strain, maximum stress theory. Both theories were studied, but the concept of Psi-Hill failure theory is somewhat different, and this uses the base of distortion energy failure theory, because earlier in case of isotropic material we know maximum stress theory, maximum strain theory, distortion energy theory, but Psi-Hill failure theory take the reference of this maximum distortion energy theory. Is it okay? And with the basis of this maximum energy of distortion theory, this von Mises concept, which was used for the distortional energy yield criteria for isotropic material, so that is applied by Psi-Hill for anisotropic material. Is it okay? For this composite lamina, when we use this concept of composite material, obviously orthotropic, anisotropic, that concepts are get bound with this particular concept of material property. Is it okay? Whenever material was isotropic, at that time maximum distortion energy theory is sufficient. So distortion energy or maximum distortion energy failure theory, that is the identification of the von Mises. Is it okay? See, in case of maximum strain theory, whenever maximum strain concept, the failure happens due to the maximum strain, and this was developed by Saint Venant, and the failure happens based on the maximum energy, distortion energy theory. This particular concept that is introduced by von Mises. Is it okay? So von Mises criteria, when it is used, it is based on the energy. Is it okay? So when the concepts comes with the energy, then that is von Mises criteria. And when concepts comes with maximum strength, then that is the Saint Venant's criteria. Is it okay? Besides this, whenever shear concept comes, then it is a Tresca. Okay. So let us come to this particular theory, maximum distortion energy theory. Whenever the material is isotropic in nature, then this theory is based on distortion energy failure theory of von Mises. Is it okay? Von Mises distortional energy yield criteria for isotropic material is applied to anisotropic material, then that becomes the Psi-Hill type of theory. Is it okay? So distortion energy is actually part of total strain energy in the body. So during you know that in your second year you have studied the chapter which was related with the strain energy, and in that strain energy we have seen that how this particular energy possessed by any body is calculated, because whenever changes in happens, means work done, various forms of works are there. The work done or various forms of works, inside that one kind of work is that wherever force is applied and displacement happens, deformation happens in the material. So force applied into deformation happening inside the material, this particular product gives the that energy possessed by that body. Is it okay? In case of this strain energy concept, we have multiplied stress into strain, and we have taken consideration of average. Means initially when force is not there, then it is considered to be zero, and whenever it is maximum, then it is stress into strain. But if we take average of that, then one half into stress into strain, that is considered here. Is it okay? So by substituting and by calculating per unit volume, etc., we have used different formulas. Later on we have compared that particular cases in different kind of forces. But if we take into consideration the concept of distortion energy, they are actually a part of total strain energy in the body. Is it okay? So energy possessed by body, which we know, the concept of energy possessed by that body, that we know, that is converted into the strain energy. and that strain energy in the body, if we try to plot on the graph also, if we will apply the force, if strain is there, stress is there, then this area under the curve of this stress strain, that is considered to be a part of strain energy. Is it okay? In case of distortion energy, it is an actually part of total strain energy possessed by that particular body. The strain energy in the body consists of two parts. One due to change in volume, which is called as a dilation energy. Is it okay? See the concept. Whenever there is a change in volume, because we know that bulk modulus, change in volume to the original volume, that particular concept we are using while calculating the elastic constants. So bulk modulus is one of the elastic constant which come across with the change in volume. Is it okay? So change in volume to the original volume, that particular ratio gives the bulk modulus. Is it okay? So here the strain energy in the body consists of two parts. One due to the change in volume and called the dilation energy, and the second is due to a change in shape and is called as distortion energy. Is it okay? See, these two things which are very important, you should keep in mind that whenever the concept comes to the volume, change in volume, then it is concept of dilation, and whenever there is change in shape, then it is concept of distortion. Distortion happens means shape changes, and dilation happens means volume changes. Is it okay? These two things are relative with each other but somewhat different. Whenever the concept of shape comes, there is word used is distortion, and whenever the concept of volume comes, then there is word used as a dilation. Is it okay? The basis of this particular theory, Sai-Hill failure theory, the basis is one Mises stress, one Mises theory, and these two notations, now you should understand what is meant by distortion and what is meant by dilation. Is it okay? So dilation energy, and second is due to shape changing, that is the distortion energy. Now it is assumed that failure in the material takes place only when distortion energy is greater than failure distortion energy. Is it okay? Distortion, this particular word we are using reference to shape. The shape is changing, but for each and every material it is assumed that there is specific what we can say as a energy possessed by that body. Due to application of load, some amount of change in shape happens, and then that is counted. But when we take the reference that this energy possessed by that body is crossed by the applied load, the applied load is too much heavy, that whatever the energy possessed, the strain energy possessed by that body, and beyond that, this force creates the impact of the energy, and that energy is more than energy possessed by the body, then definitely failure happens. And with this concept, this maximum distortion energy theory of one Mises works, and same thing is applied for anisotropic material by Sai-Hill, and that's why this particular theory is considered to be a Hill theory or Sai-Hill theory. Is it okay? So failure of material takes place only when distortion energy is greater than failure distortion energy. Is it okay? So that particular material has certain energy, but due to application of load, the violation of that particular energy happens, and due to which failure gets. Is it okay? So scientist Hill adopted the von Mises distortion energy yield criteria to anisotropic material, and then Psi adopted it to unidirectional lamina. Is it okay? See, these two different scientists are there. Psi is different scientist, Hill is different scientist. So what is the work, what is the contribution of Hill in this theory? Hill adopted von Mises distortion energy yield criteria to anisotropic material. While what is the contribution of Psi? The contribution of Psi is he adopted it to unidirectional lamina. Is it okay? When the lamina is considered to be unidirectional in nature, and for that particular case of material, when this maximum distortion energy theory is applied, so that credit is in the literature of psi. And secondly, the particular theory of maximum distortion energy theory applied to the anisotropic material, that work is carried by scientist Hill, and that's why Psi Hill particular criteria, which was started with the concept of one misses and one misses stress this particular distortion energy theory, which was applied earlier for the isotropic material, and later on the changes in that theory happened, which was applied by the Psi, and second one is the Hill. The Psi and Hill together came, and they formed this particular theory, which is considered to be Psi Hill theory. The concept is no same, fundamentally same, then base is same. However, this particular theory is applied for unidirectional lamina and anisotropic material, and then that new theory was introduced, was evolved with the name of Psi-Hill failure criteria, and that is very important in case of composite material, because many of the composites are unidirectional in nature or anisotropic in nature. Is it okay? So that's why this theory we should understand. This adoption of this Psi and Hill based on this distortion energy theory, and for that they have used the this particular equation which is here on your screen. So you can see here that if G is the shear modulus, G2 is the shear modulus in the direction 2, G3 is the shear modulus in direction 3, sigma 1 is the stress, is it okay, in the direction 1, sigma 2 is the stress in the direction 2, G1 is the this shear modulus in direction 1. So this particular theory which is given here with this particular Psi-Hill failure criteria is that G2 plus G1 into sigma square. Okay. Earlier, this sigma square, that concept was used in case of strain energy, sigma square V upon 2E. Like this we have earlier used this. Is it okay? Here G2 and G3 are the shear modulus in direction 2 and direction 3. Then G2 plus G3 sigma 1 square plus G1 plus G3 sigma 2 square plus G1 plus G2 sigma 3 square. So with these three parameters, what we can understand here, in first part of this, G2 and G3 was used in at that time sigma 1. So this basis is taken. Then G1 and G3 is when used, sigma 2 is taken. When G1 and G2 is taken, then sigma 3 is used here for the reference. So minus 2 G3 sigma 1 sigma 2. Is it okay? Minus 2 G3 sigma 1 sigma 2 minus 2 G2 sigma 1 sigma 3 minus 2 G1 sigma 2 sigma 3 plus 2 G4 tau 2 3 raised to 2. Now here G is this shear, tau is used as a shear stress. Is it okay? That shear stress is in between direction 2 and direction 3. Is it okay? In between direction 2 and 3, this shear stress tau 2 3, that concept is used. Then shear stress in direction 1 and 3, that is tau 1 3, and shear stress in direction 1 and 2, that is given as a tau 1 2. Is it okay? So the rest of three terminologies are added, three are subtracted, and first three, likewise six terms are positive while three terms are negative. Is it okay? if we try to understand these particular terms here, G2 plus G3 sigma 1 square, G1 plus G3 sigma 2 square plus G1 plus G2 sigma 3 square. Then positive term is 2 times of G4, tau 2 3 its square plus 2 times of G5, tau 1 3 its square plus 2 times of G6, tau 1 2 and it's a square. Is it okay? So the strength here important components are G1, G2, G3, G4, G5 and G6. Is it okay? Then rest is sigma 1, sigma 2, sigma 3, tau 1 2, tau 1 3 and tau 2 3. Is it okay? So whatever the concept of stresses used here, all these concept of the stresses inside which 3 are normal stress and 3 are shear stresses. Is it okay? So normal stresses in the direction 1 2 and 3, shear stresses are in the direction 1 2 2 3 and 3 1. Is it okay? Like this. So these 3 shear stresses and 3 normal stresses. Likewise 6 stresses are there. Then shear stresses inside that, the shear modulus, that is G1 to G6, that are used. However, if all these parameters, all the terms are added together and 3 terms, that is subtracted, G3 sigma 1 sigma 2, G2 sigma 1 sigma 3, G1 sigma 2 sigma 3 and 2 times of that, then it should be less than or equal to 1. Is it okay? It should be less than 1. So he proposed, the Sai and Hill combinedly proposed that lamina will get failed if this particular part, if it is less than 1. Is it okay? If it is less than 1, then this lamina will get failed due to the violation of energy possessed by that particular body. So based on distortion energy theory, Sai proposed this particular equation. So some of you, if we are interested for the any kind of analysis of the composite material, then this kind of theories will be very, very useful for you. Is it okay? Then we will try to understand then what is meant by this G1, G2, G3, G4, G5, G6. All these are the strength criteria. So sigma 1, when this particular concept we are using, we know now that which particular stress it should be considered as it is positive. That's why tensile, and up to what limit? Up to its ultimate tensile strength. Is it okay? So this particular stress sigma 1 is the maximum stress possessed by that particular body in the direction 1 when it is tensile in nature. So sigma 1 in the direction of 1 and tensile in nature. So tensile force applied in the direction of 1 due to which stress produced is sigma 1. Is it okay? Try to understand this. Tensile force is applied in the direction 1. Due to application of this tensile force in the direction of 1, the tensile stress is generated, and that tensile stress is sigma 1. So that is again sigma 1 to the base ULT ultimate, and it is T. T means tensile in nature. Is it okay? So when sigma 1 is used equal to sigma 1 T, then unidirectional lamina will fail. Is it okay? So for that purpose, the equation used here, it is G2 plus G3 sigma 1 tensile in nature is it equal to 1. Then the same concept is applied in the direction 2. As far as concerned with this direction 2, when this concept is applied in the direction 2, then sigma 2 is equal to sigma 2 T. Is in tensile in nature, but the direction is second direction, and that is again applied to the unidirectional lamina. Is it okay? Then lamina will fail. Is it okay? So in that case, this both equations, by considering the assumptions of 1 and 2 only, because in the first assumption Sigma 2 is not present there as it is unidirectional lamina. Only in one direction it works. In another direction there is no stresses. So sigma 2, sigma 3 that are considered to be equal to 0. Then if we consider the sigma 2 and sigma 3 as a 0, then this will become 0. Sigma g1 plus g2, this particular part will become 0. This will become 0. This is again become 0. Sigma 3 is 0. Sigma 3 is 0. And know all the remaining parameters also. So only a remaining parameter, only a considered parameter is only this first part, G2 plus G3 into sigma 1, it's a square, which is ultimate and tensile in, so which is equal to 1. Then this equation get reduced here, then unidirectional lamina will fail when the equation is G2 plus G3, means shear modulus in the direction of 2 plus shear modulus in the direction of 2 into the stress produced, which is tensile in nature. If we take its a square, then it will become equal to 1. So that is very interesting. Is it okay? Then is sigma 2, that is also this stress acting in the direction of 2. In this equation, sigma 1, sigma 3 is kept as 0. Shear stresses are kept 0. And then G1 plus G3 into sigma 2T, that only remains here. Is it okay? Similarly, if it is in the third direction, this is only possible. If only tau 1 exists, tau 1 2 is only exists, then this is the thing. Is it okay? So with this, all these equations are solved together. So we will consider these are the boundary conditions like this. This equation 1, 2, 3, 4, these four equations are simultaneously solved in order to identify the values of G1, G2, G3, G4 here. Is it okay? And then whatever the final equation we get here, so that equation that is referred here, sigma 1 upon sigma 1 tensile in nature, ultimate tensile strength, it's a square. Sigma 1 is the any stress and sigma 1 is the ultimate tensile. This is at this stress failure will happen. Sigma 1 T ULT, that it indicates the maximum ultimate tensile strength of that particular material. Is it okay? So this is strength and this one is the stress. To stress to strength, it's a square. Similarly, it is the product of two stresses and this is again strength. So the strength in the direction of 1, strength in the direction of 2, and shear strength at ultimate point, and then these stresses are there. Is it okay? So with this, the psi heel failure criteria works here. Is it okay? So with this particular concept of psi heel, we will complete the part of psi heel here. Anybody